This video lesson is going to talk about gas law stoichiometry. The concept is basically using ideal gas law and stoichiometry together in the same problem. When starting out these problems, the first thing you always want to do is write out your PV equals nRT variables. This is important because this is going to be the way that we determine whether or not we're going to do stoichiometry first and a gas law second, or gas law first and stoichiometry second. So I'm going to make a little table here and talk about each side separately. What happens if you have only one missing variable? This would happen if you wrote out your PV equals nRT variables and you're missing one. If you are missing one variable, it is going to be n, or number of moles. If that is the case, you want to do the gas law first and solve for that missing variable n. Once you've solved for n, the next thing you're going to do is take that n and answer the question doing stoichiometry to solve for the missing mass. Now the other type of problem you will see is two missing variables. Now if you're missing two Pivnert variables, the two variables that are going to be missing, one will be n and the other will be either p, v, or t. If that's the case, you're going to want to do stoichiometry first to solve for n number of moles. And once you have done the stoichiometry to solve for n number of moles of gas, then you can stick n into Pivnert and solve for the missing variable. So you do the gas law second. And then you can solve for the missing variable. Now I will zoom back out here so you can get a good look at this table, and that way you know how to tackle these problems moving forward. I'm going to do an example of each. One where you do gas law first and stoichiometry second, and one where you do stoichiometry first and gas law second. The first thing I'm going to do is I'm going to write out my Pivnert variables to determine if I'm missing one or two variables. If I look at what's given to me in the problem, I've got a volume of 2.0 liters, I've got a temperature of 305, and I in fact have a mass of 3.50 grams of MgCl2. But that in fact doesn't give me the moles of H2, which is what I'm trying to get to eventually. I'm trying to find an unknown pressure of H2 gas. So when I look at my Pivnert variables, I'm in fact missing two variables. So based on the last slide, this means that I'm going to want to do the stoichiometry first and then do the gas law second. Another indication that I'm going to do stoichiometry first is that I'm given a mass in the problem of 3.50 grams of MgCl2. And that would indicate to me that I need to do stoichiometry first, solve for moles of H2, then plug the moles in here and solve for P, only once I've done the stoichiometry first. So I'm going to zoom in right here, and I'm going to do the stoichiometry starting with the 3.50 grams of MgCl2. This is a mass to mole stoichiometry problem, and it's going to be done in 3 steps. It's actually 2 steps. The first step is to calculate how many moles of MgCl2 that I have by dividing by the molar mass. I pull up my periodic table, I add up 1 magnesium and 2 chlorines, and I get 95.20 grams of MgCl2 for every 1 mole. Now the last thing I want to do is take the moles from the balanced chemical reaction of MgCl2 and put that on the bottom, and I want to put moles of H2 on top. And I go back to my balanced chemical reaction up here, and I pick out MgCl2 and H2. For every 2 HCl's, just kidding, I don't want HCl, I want H2. So for every 1 H2, it's 1 MgCl. 1 to 1 mole ratio, and now I do the stoichiometry, and I get an answer of 0.0368 moles of H2 gas. Now I can plug that in right here for my moles of H2 gas, 0.0368 moles, and now I have everything I need to solve for P using Pivnert. So I give myself a little bit of room and I solve for P. Let's set up the problem first. I write out P times 2 equals 0.0368 times 0.0821 times 305, and I divide by 2 on each side to isolate P by itself, and I will get an answer of 0.460 atmospheres. If I zoom out and give you a good look at the problem, you'll see that I did the stoichiometry first because I had two missing variables, one of which was n and another was p. Once I did the stoichiometry, I took that answer and I plugged it in right here for number of moles, and then I could do the Pivnert problem solving for P, and eventually getting this answer of 0.460 atmospheres. Now the second example I'm going to do is one where you do the gas law first and the stoichiometry second. The first indication that I'm going to do the gas law first is that when I write out my Pivnert variables, I have everything except for N. Now my pressure is 150 kPa, and so I'm going to need to divide that by 101 to get it into atmospheres, so I'm going to do that first. When I take 150 divided by 101, I get 1.49 atmospheres. Now the rest of the numbers are fine. I got 4.0 liters, I don't know my moles, my R is 0.0821 liters times atmospheres over moles times Kelvin, and finally I have 315 Kelvin. So I have everything except for N. So what I'm going to do is use the ideal gas law to solve for N. So let me zoom in here so I can get this all on one line. Next thing I need to do is solve for N. So the first thing I'm going to do is I'm going to multiply these two numbers on the left together to get 5.96. Then I'm going to set that equal to N, and then I'm going to multiply these two numbers together to get 25.8615, and finally I'm going to divide by 26.8615 on both sides to isolate N, and N will be equal to 0.230 moles of gas. Specifically, the gas in question is H2 gas. So the next thing I'm going to do is actually do the stoichiometry, because I got to take that moles of H2 gas and solve for grams of HCl. So now I'm going to set up mole to mass stoichiometry. I'm going to take this number and I'm going to start using 0.230 moles of H2. And I'm going to do the mole to mole ratio. Mole of H2 on the bottom, moles of HCl on top. And then I'm going to go up to my balanced chemical reaction and figure out for every 2 moles of HCl, it's 1 mole of H2. So I go back down here, 2 moles of HCl, 1 mole of H2. Finally, I take 1 mole of HCl and I figure out how many grams of HCl there are, and there are 36.46 grams for every 1 mole. Zoom out, and so I can see the whole number, multiply these together, and I get 16.8 grams of HCl, and that's my final answer. Now taking a look at the whole problem again, first of all, I use my Pivnert variables to solve for N number of moles of H2. And then I use that answer to do the stoichiometry part, which is mole to mass stoichiometry, solving for grams of HCl. That takes care of this video lesson. Thanks for listening.